Hi everyone, welcome back on your own YouTube channel Vinay Magic Maths. Myself Vinay, the mathematics mentor. Hope you guys are doing much amazing. In today's class, we are going to continue with ongoing videos of parabola. So let's see our today's goal, what we are going to study in today's class. So first of all, we will start with parametric equations of parabola. Thereafter, we will see the parametric equations of standard parabolas as well as parametric equations of shifted parabola, right? Thereafter, we can move towards tricks to remember how to, then we will see how to remember the parametric equations as well as the general point on any curve of standard parabolas, also of shifted parabola. Post that, we can move towards questions practice as well as we will see some of the previous year asked questions so as to get our better practice on this particular topic. So let's start with the first topic, that is parametric equations of parabola. So let's start with standard parabola y square equals to 4ax. So for example, if we have our standard parabola y square equals to 4ax, we will be having our standard equations of parabola, that is y square equals to 4ax. Now, what is parametric equations? First of all, let us understand the term parametric has been derived from parameter. So we will be having one parameter. Based on that, so parameter t will be here. So what this t will denote, once we will change the value of t, we will see the coordinates and the parametric equations. So once we will change the different value of t, we will be getting different points on this curve. Similarly, why is it so important? Because once we will assume any point on this parabola, let's say we will assume alpha comma beta. So we are having two variables, but once we will study this parametric form, so we will be having one parameter t on both coordinates, whether it is x coordinate or y coordinate. So our number of variables has been reduced from 2 to 1. So this is also going to play a very important role in further calculations, also for derivation parts of point of view, right? So let's see how we will define this. So for example, if we have to assume any point P on this curve, let's start with point P as x comma y. Now we are having equation of parabola as y square equals to 4ax. From here we can rearrange it as y square upon 4a is equals to x. From here we can rewrite it as y square upon 4a, we can multiply by a in numerator as well as in denominator. This has been reduced to like this. Now we can rewrite it as y upon 2a whole square. This term has been reduced to y upon 2a whole square multiplied by a is equals to x. Now here y upon 2a, we can put the value of y upon 2a is equals to t. This t is also known as parameter, as we have seen. So this t is going to play the role of parameter. So we can rewrite it as y is equals to 280. So from here we have achieved y is going to be equals to 280, where t is a parameter and the value of t is y upon 2a, right? So now let's say this is equation number 1. Once we will put the value of y upon 2a equals to t, we know that. So we can put the value of y upon 2a as t. So this will become t square multiplied by a is equals to x. So we can rewrite it as x is equals to 80 square. Now we have started point P as x comma y. Now we have obtained the value of x and y in terms of t. So what we can rewrite the value of coordinates of point P as, we can rewrite it as 80 square comma 280, and x equals to 80 square, y equals to 280. These two particular equations will represent parametric equations of parabola y square equals to 4ax. So x equals to 80 square and y equals to 280 are known as parametric equations of parabola y square equals to 4ax. So I hope we are clear with this point. So from now, if we have to assume any general point P on parabola y square equals to 4ax, we can assume that point to be 80 square comma 280. So this was in case of y square equals to 4ax. Similarly, let's see for other cases for standard parabola. Let's say if this parabola would have been y square equals to minus 4ax, so minus 4 here it will come, and the graph will shift towards, its opening will be towards leftwards. So in this case, parabola opening will be towards leftward. Like this, the parabola will be drawn in case of y square equals to minus 4ax. So let's say point P as x comma y. This is the equation of parabola y square equals to minus 4x, and we have assumed the point P as x comma y. So here also we can rewrite it as this. Minus sign will be here also. And now we have assumed y is upon 2 equals to t. So from here we have obtained y equals to 280. There is no change. But Once we will replace the value of y upon 2a as t, once we will put this value as t, so it will be minus t square multiplied by a equals to x. So this will become x is equals to minus 80 square. So point P will be minus 80 square comma 280 in case of y square equals to minus 4ax. So you can see, we have seen as of now in case of y square equals to 4ax, the general point P is going to be 80 square comma 280, and the parametric equations will be x equals to 80 square and y equals to 280. But in case of y square equals to minus 4ax, y coordinate will remain positive. The x coordinate will be minus 80 square, since we have taken the minus sign with 4a also. So this is the trick to remember. Also, we will see the flowchart later on. So now let's see derivation for x square equals to 4ay also. For x square equals to 4ay, the graph will be drawn and its opening will be towards upward. So in case of parabola x square equals to 4ay, this is the vertex. This equation will be x square is equals to 4ay. So let's assume any point P on this curve as x comma y, point P as x comma y. So since we have the equation x square is equals to 4ay, we can rearrange it as x square upon 4a is equals to y. Now we can rewrite it as x square upon 4a multiplied by a in numerator and denominator. So we can rewrite it as x upon 2a whole square multiplied by a is equals to y. Again, similarly, we can put x upon 2a. Put x upon 2a is equals to t. This t is known as parameter. From here, we can obtain x is equals to 280. Since we have assumed x upon 2a as t, we can put x upon 2a as t. So we can obtain here t square multiplied by a is equals to y. So y will be equals to 80 square. So from now onwards, if we have to assume any general point P on the parabola x square equals to 4ay, the coordinates of that parabola will be, the coordinates of point P will be 280 comma 80 square. The derivation we have seen here. But what happened if our parabola would have been x square equals to minus 4ay, right? So similarly, after noting this, you can see the derivation for minus 4ay, x square equals to minus 4ay. So minus sign will come here also and here also, right? Similarly here also. Again, we have put x upon 2a equals to t. So x will be remain plus 280. Now, since we know x upon 2a, the value of x upon 2a is t, so it will be minus t square multiplied by a equals to y. So y coordinate will become minus 80 square in case of x square equals to minus 4ay. And the graph of x square equals to minus 4ay will be opening towards downward. So I hope I have made my points clear to you that in case of x square equals to 4ay, the general point P will be x equals to 80 and y coordinate will be 80 square. But in case of x square equals to minus 4ay, the general point P will be coordinate x will be 280 and coordinate y will be minus 80 square. Correct? So what happened if instead of the vertex of parabola, instead of at origin, if it is shifted towards other points other than origin? So in that case, what will happen is, since we have seen in the first class that whenever we will be having shifted parabola, we will convert it towards let's say if it is our shifted parabola is something like this, y minus k whole square is equals to 4a x minus h, like this. So we know we can rewrite it as capital Y square is equals to 4a capital X. And again, whatever we have studied till now, for example, in case of y square equals to 4x, we know our general point will be 80 square comma 280. So we can substitute capital X equals to 80 square and capital Y equals to 280. Since capital X is equals to x minus h, so it will be x minus h equals to 80 square and y minus k will be equals to 280. Similarly, we can write x equals to h plus 80 square and y will be equals to k plus 280. In case of shifted parabola, likewise in all the three other cases, we can get the result like this only. We just need to convert it towards y minus k equals to 4a times x minus h. In case of x square equals to 4a y, it will be x minus h whole square equals to 4a times y minus k. So suppose that we can compare with x square equals to 4ay. and we know the general points of x square equals to 4ay. We can substitute capital X equals to 280 and capital Y equals to 80 square. Likewise, we can obtain the result. So we have seen the derivation of parametric equations of parabola, of standard parabolas, also as of shifted parabola. Now let's see summarized flow chart for parametric equations of standard parabolas, right? So now we have 4 standard parabolas. For every standard parabola, we have been written parametric equations as well as general point or parametric coordinates. So now we have already seen the derivation part. Now let's see how to remember this, how to revise this again and again. So what is happening here is, if you will observe here, the 80 square term is will come with either plus sign or with minus sign, but 280 term is always positive. You can see here also it is positive, 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 positive. In all the 4 cases, 280 term is always positive. It is for sure. When it comes to 80 square, it will come plus. If the sign of 4a is positive, it means that 80 square will always be positive. Similarly, if sign of 4a is negative, it will be minus sign here. If sign of 4a is positive, it will be also positive. Similarly, if it is minus, it is also going to be minus. So 80 square will be plus minus depending on the sign of 4a, correct? On behalf of that, we can arrange this. And now we have to remember one parametric equation. For the first case, if we can remember this, x equals to 80 square and y equals to 280, then we can easily write all the 4 other cases, all the 3 cases. We will copy this in second for say y square equals to minus 4ax, right? And thereafter, as we know, if it is minus sign with 4a, it means 80 square will come with minus sign. Similarly, to obtain the third one, we just need to exchange the value of x and y in case of third case to obtain the third case. And once we have obtained the third case, we can just copy this to fourth case also. And since here it is minus sign, so 80 square will come with minus sign. So I hope you will remember this again and again with this trick. It will be very helpful to you. Now what happens if there is shifted parabola? In that case, what will happen is we will convert this to our equations to y plus minus k. We can convert to capital Y square equals to 4ax. Likewise, capital Y square equals to minus 4ax, capital X square equals to 4a capital Y, capital X square equals to minus 4a capital Y. And we can put these values, capital X equals to 80 square, capital Y equals to 280. And let's say capital X value is x minus h, then it will become x minus h equals to 80 square. Similarly, it will become y minus k equals to 280. From there, we can write the parametric equations as well as parametric coordinates for shifted parabola also. So I have cleared the parametric equations of parabola to you for standard parabolas as well as for shifted parabolas. Now let's move towards the questions. As of now, we have seen the theory part and we have seen the derivation part, how to derive the parametric equations of standard parabolas as also of shifted parabolas. So now let's implement those concepts into our questions. So let's start with the first question as write the parametric equations of below parabolas. So we have been given multiple parabolas equations. We just need to write the parametric equations for these corresponding parabolas. So let's start one by one. So we have the first question as y square is equals to 16x and we need to write the parametric equations of this parabola, correct? So we have seen in case of, since this is corresponding towards, this comes into the family of y square equals to 4ax category. So for this parabola, we have seen the parametric equations to be x equals to 80 square and y equals to 280, right? So now, once we will compare with this y square equals to 4x, we will compare x square y equals to 16x. We will be getting small value a as 4. So now we can write x is equals to 80 square and y is equals to 280. That means 2 multiplied by 4 multiplied by t. So our equation has become 4t square and x equals to 4t square and y equals to 8t. So this is the right answer for our first question. So this is the parametric equation of parabola y square equals to 16x. So now let's see second part. So solution of second part is we have x square equals to minus 32y. So we can compare with x square equals to minus 4ay. So once we will compare with x square equals to minus 4ay, we can see the value of a as 8. And from here we know in this case we have been written as x is equals to 280 comma minus 80 square. Since 280 term will always be positive, this is for sure we have seen, and 80 square will be minus because with minus 4 there is minus sign. Sorry, with 4a there is minus sign, so with 80 square will be with minus sign itself. So now we know the coordinates of x and y in case of x square equals to minus 4ay. So now we can write for this also as x is equals to 280. X is equals to 280 into t, and y will be equals to minus a into t square. So finally we got x is equals to 16t and y equals to minus 8t square. I hope this is clear to you. So first, second we have done. Now let's move towards third part. So in third part we have been given y square equals to minus 48x. So again we will compare with y square equals to minus 4ax. So third is y square equals to minus 48x. So now we will compare with y square equals to minus 4ax. From here we can write the value of a as 6 will be 12. And now in case of this, we know x is equals to minus 80 square and y equals to 280. So similarly we can write for this case also as x is equals to minus a into t square and y will be equals to 2 multiplied by 12 into t. So x will be equals to minus 12t square and y will be equals to 24t. So this will be the parametric equation of parabola y square equals to minus 48x. So let's see fourth part. We have been given x square equals to 8y. So now fourth part is x square is equals to 8y. So we will compare with x square is equals to 4ay. In this case we know x is going to be equals to 280 and y is going to be equals to 80 square. Since we are aware about this parametric equation for x square equals to 4ay, we will compare and write the value of a is equals to 2. So we can write the parametric equations as x is equals to 280. So 2 multiplied by a multiplied by t, and y will be equals to a into t square. So now we can write finally as x is equals to 4t and y is equals to 2t square. So this is the parametric equation of parabola x square equals to 8y. Now let's see the fifth part. Solution for fifth part. We have been given x minus 4 whole square is equals to minus 16 times y plus 7. I will recommend you to do by yourself first before seeing the solution. So since this is the case of shifted parabola, the vertex will be at 4 comma minus 7. Now what we have to do, we have to write this as x square equals to minus 16 capital Y, and we will compare with x square is equals to minus 4ay. In case of this, we know x is going to be equals to 280 and y is going to be equals to 80 square with minus sign, because 4a is with minus sign, so 80 square will come with minus sign. So now we know this one. For standard parabola x square equals to minus 4ay, we will compare and write capital X is equals to 280. In case of this, we know the value of a is going to be equals to 4. A is going to be equals to 4, so we can write capital X. We can write capital X is equals to 280. Capital X equals to 280, it means, and capital Y equals to minus 80 square. So capital X means x minus 4 is equals to 2a. A is 4, so we can write 8t, and y plus 7 will be equals to minus 4t square. Now we can write it as x is equals to 4 plus 8t and y will be equals to minus 7 minus 4t square. So this collectively is known as parametric equation of parabola x minus 4 whole square equals to minus 16 times y plus 7. So in case of shifted parabola, we have converted this to compare with capital X square equals to minus 16 capital Y, and we have seen x square equals to minus 4ay. In this case, we know the parametric equations as x equals to 280 and y equals to minus 80 square. Now we have compared this, so we have written capital X equals to 280 and capital Y equals to minus 80 square, and we know the value of capital X is x minus 4. From here we can write x minus 4 is going to be equals to 8t, because value of a is 4, and y plus 7 will be equals to minus 4t square, right? From here we can write x will be 4 plus 8t and y will be equals to minus 7 minus 4t square. These are the solutions for all these 5 parabolas. So let's see our next question as write parametric equation for y equals to x square plus x plus 1. So in this case, how we will proceed? Let's see. First of all, we will convert this to standard form of parabola, and by how we can do that, we need to convert it to perfect square, right? So we know that to convert it into perfect square, we need to make the coefficient of x square as 1. Since it is already 1, so we can proceed with that. And next step is whatever the coefficient of x will be there, we need to divide by 2. Since coefficient of x is 1, we need to divide by 2, and this we will create perfect square. Since we have used these two terms to write this equation, so to write this term, so in this term 1 by 2 whole square will be coming, so we need to remove that. So we need to subtract 1 by 2 whole square from here, and plus 1 is the third term. So now it can be written as x plus 1 by 2 whole square plus 3 by 4, and again we can rewrite it as y minus 3 by 4 is equals to x plus 1 by 2 whole square. Now we can write it into perfect square, standard form of parabola as capital X square equals to 4a capital Y, where capital X is equals to x plus 1 by 2 and capital Y is y minus 3 by 4. So we can compare with this and we can write, first let me write one more step. So it can be written as x plus 1 by 2 whole square is equals to y minus 3 by 4, and next, as a next step, we can write it as x square equals to 4a capital Y. From here we can compare 4a is equals to 1. So 4a is equals to 1, it means a is going to be equals to 1 by 4 in this case. So what does this a signifies? In parabolas we know a is the value of from vertex to focus. This is the distance of from vertex to focus is known as the distance as small a. So now we got the value of a, we need to write the standard equations. So we know in case of x square equals to 4a, we can write x equals to 2at and y equals to at square. So as a next step, we can compare with this and write x equals to 2at means capital X is equals to 2at and capital Y will be equals to at square. We know the value of a and we know the value of capital X and capital Y. So we can substitute, we can get x plus 1 by 2 is equals to 2at. A is 1 by 4 into t. So from here we can write x is equals to minus 1 by 2 plus t upon 2. This is the x. In terms of y, now for capital Y is equals to at square. So we can write y minus 3 by 4 is equals to at square. A is 1 by 4 into t square. So y will be equals to 3 by 4 plus t square by 4. So x is equals to minus 1 by 2 plus t by 2 and y equals to 3 by 4 plus t square by 4. So this is the parametric equation of parabola y equals to x square plus x plus 1. So we have seen how to proceed with this type of question. We need to convert it into perfect square. Post that we can compare with the standard form of parabola. Since this is a shifted parabola with vertex at minus 1, 2 and with vertex at minus 1, with vertex at minus 1 by 2, 3 by 4. So this parabola is drawn something like this, if you remember. Since we know the vertex minus 1 by 2, 3 by 4, so minus 1 by 2 and 3 by 4 will come here. After putting x equals to 0, we can get y equals to 1. So it means that parabola will be drawn something like this. This will be 0, 1 and the vertex is minus 1 by 2, 3 by 4. This is the sketch of this parabola y equals to x square plus x plus 1. So let's proceed towards next question. Our question is, find the value of parameter t for which point P 4, 4 on the parabola y square equals to 4x. So we have been given one point and the parabola, we need to find the parameter t. So since we know that in case of parabola y square equals to 4x, let's say this is the point P 4, 4, and we have understood that we have seen this coordinates can be written as, point P can be written as at square, 2at. So this is the t. So what will be the value of this particular t in case of point P 4, 4? So let's see, we will compare. So we can write at square as 4 and 2at as 4. So now we will solve simultaneously. We can get, since in case of parabola y square equals to 4x, the value of a is going to be equals to 1. It is for sure. So from here we can write, this is equation 1 and equation 2. From equation 1 we can write t square equals to 4 and here it is 2t is equals to 4. So from this equation we can write t is equals to plus minus 2. From here we can write t is equals to 2. So now which value of t is feasible for point P 4, 4? on the parabola y square equals to 4x, which is correct and which has to be taken and which has to be excluded. Let's see. So point t, so parameter t should be satisfying both the equations, both the coordinates, because it is going to take value of point p 4 comma 4 if t is going to satisfy both the coordinates, right? So in that case, we will take intersection and we will come up with the value of t as 2. So we can generalize point p as t square comma 2t. So if we will put the parameter t as plus 2, so we can get the point p as 4 comma 4, which is required for this case. What happens if we will put the parameter t as minus 2 in our general point p as t square comma 2t, then what will happen is minus 2 whole square, this is t square comma 2t, 2 multiplied by minus 2. So point p dash, let's say this is p dash, it will become 4 comma minus 4. So p dash will lie here and this coordinate will be 4 comma minus 4. So once we will change the parameter t, we can get the different points on this curve. This is the meaning of parameter, right? So for our question, the value of t will be plus 2. This is the answer. But if we will put the value of t as minus 2 in our general point p, we will be getting the point as 4 comma minus 4. So let's move towards next question. Our question is, find the value of parameter t for given below points on the parabola x minus 2 whole square equals to 12 times y minus 3, and the point p is 8 comma 6 and point q is minus 10 comma 15. So we have been given one shifted parabola and we have been given 2 points. We need to find the parametric parameter t for these 2 points. So let's see how we will approach. First of all, we will find the parametric equation of this parabola. Thereafter, we can compare with the coordinates. So we have been given x minus 2 whole square is equals to 12 times y minus 3. So we can compare with x square equals to 4ay. Since we know in case of x square equals to 4ay, we can write the parametric equations as x is equals to 2at and y equals to at square. After comparing, we can write value of a is equals to 3. Since 4a equals to 12, so a will be 3. So we can write capital X is equals to 60 and capital Y equals to 3t square. And instead of capital X, we can write x minus 2. So x minus 2 is equals to 60, and in place of capital Y, we can write y minus 3, and this is equals to 3t square. From here, we can write x is equals to 2 plus 60 and y is equals to 3 plus 3t square. So point P has been given 8 comma 6. So we can put we can put value of x as 8 and value of y as 6, and we can find the common point t. So let's see, we can write 8 is equals to 2 plus 60, and we have y coordinate as 6, and this is equals to 3 plus 3t square. From here we will solve and get the value of t. So from here we can get the value of t as plus 1, and from here we can write 3 upon 3 equals to 3t square. That means t is equals to plus minus 1. So we need to take the intersection point, because parameter t should satisfy both the coordinates, right? So parameter t will be plus 1 in case of first point as the final answer, because we need to take the common point, common value of t, which is satisfying the coordinate point p, 8 comma 6. So for first point, we have the t is equals to 1 as a final answer. So for second point, we have minus 10 comma 15. So we can write minus 10 equals to x coordinate is 2 plus 60, and so we can solve it. Let me write y coordinate also. Y coordinate is 15 is equals to 3 plus 3t square. So we can write minus 12 upon 6 minus 2. So t will be minus 2, and from here we can write 12 upon 3 equals to t square. So t will be plus minus 2. So now we need to take the common point. So this is here minus 2. From here also we will take minus 2. So t equals to minus 2 will be our final answer for parameter t equals to minus 2 for point q, minus 10 comma 15. So point p 8 comma 6 on this parabola, we have parameter t as plus 1, and to get the point q on this parabola, we need to put the parameter t as minus 2. So this was our final answer. Let's see our next question as the locus of a point which divides the line segment joining the point 0 comma minus 1 and the point on the parabola x square equals to 4y internally in the ratio 1:2 is, we have been given 4 options. This question was asked in JEE Mains 2020. So let's see how we will approach towards solution. We have been given a point 0, -1. We have been given a point, let's say this is point A, 0, -1. And we have been given one general point on parabola x square equals to 4y. So to take any general point on parabola x square equals to 4y, what we need to take, the coordinate we can take, if we have to take any general point on parabola x square equals to 4y, so we can take 280, 80 square. In case of this parabola, we have the value of a as +1. So we can take point B as 2t, t square. And now we have been given and a point on the parabola, the locus of a point, let's say any point P here with coordinate h, k. We need to find the locus of this point P. So what is locus? Locus is a moving point which moves in such a way that it follows certain geometrical conditions, right? So in this case, point P will move in such a way that it will join point A and point B always in the ratio. It will divide internally in the ratio 1:2. So now we will apply section formula here. So to write x coordinate of point P, we can write h equals to, we'll multiply with this part and like here. So 1 will multiply with the x coordinate, it will be 1 into 2t plus 2 into 0 divided by 3. So k will be written as 1 multiplied by t square plus 2 multiplied by -1 divided by 3. So from here we can write 3h is equals to 2t. We can write 3h upon 2 is equals to t. And from here we can simplify it as 3k is equals to t square minus 2. Now we can replace the value of t in this equation. This is equation number 1. This is equation number 2. So from equation 1 and 2 we can write, from equation 1 and equation 2 we can write 3k is equals to t square will be 3h upon 2 whole square is t square minus 2. Now we can replace h, k with x, y. Replace hk with x, y. So we can simplify it as 3y is equals to 9x square upon 4 minus 2. We can multiply by 4. So we will be getting 12y is equals to 9x square minus 8. So as to get answer, we can write 9x square minus 12y is equals to 8 as the final answer. Option A will be the right answer. So what we have done, this type of questions has been asked in previous years multiple times. I will give you one question as a to be done by yourself as a homework of this type only. So this question is going to be this question is going to be very important because this type of question has been asked multiple times. So it is very expected that it can be asked in coming examination also, right? So what we have done is we have been given one point A which is 0, -1, it is a fixed point, and we have to assume point B as a general point on the given parabola. So we must be aware about how to take general point on this parabola. So we can take as 2t, t square in this case. Now point P is the moving point, so we can assume it as its coordinate as h, k. This condition is point P will divide AB internally in the ratio 1:2. We can apply section formula and we can write the coordinate of h and k after that, after simplification, and we can substitute h, k with x, y to get the final equation of Locus. So let's move towards the next question of our topic. So we have been given, let the focal chord PQ of the parabola y square equals to 4x makes an angle of 60 degree with the positive x-axis, where P lies in the first quadrant. If the circle whose one diameter is PS, S being the focus of the parabola, touches the y-axis at the point 0, alpha, then 5 alpha square is equals to. So let's see how we will proceed. So we have been given parabola y square equals to 4x. So we have been given parabola y square equals to 4x, and we have been given a focal chord. So as of now, we are just known that what is focal chord. So focal chord is the chord which passes through the focus. This is the main point that we need to that we should be aware about focal chord in this problem. Focal chord is the chord which passes through focus of the parabola. In case of parabola y square equals to 4x, the focus will be at 1, 0. It means that our focal chord will be passing through this focus. So our focal chord, let's say it is PQ. So PQ will pass through point S, and the coordinate of S is 1, 0. So this is the rough sketch, of our problem. So now what we have been given, this makes an angle of 60 degree with positive x-axis in anticlockwise direction, and this PS, assuming PS as the diameter of one of the circle, once we will draw the circle, it will touch y-axis. So let's see, the picture will be something like this. So this is PS, and this will touch y-axis at 0, alpha. So this is the complete picture. So this circle, once we will draw a circle considering PS as diameter, so we can draw a circle like this, which will be touching y-axis at 0, alpha. This is y-axis. So now, since we are aware about the fact that we can assume any general point P on the parabola y square equals to 4x, and that point P we can take as, so we can assume point P as at square. Here a is 1, so it will be t square comma 2t. So we know that we are aware about the point P and point S. So we know we can write the slope of PS as tan 60 degree, and it will be equals to 2t minus 0 upon t square minus 1. Since tan 60 degree is root 3, so it will be root 3 is equals to 2t upon t square minus 1. Now we need to simplify it. So root 3t square minus root 3 is equals to 2t. So we can rearrange it as root 3t square minus 2t minus root 3 is equals to 0. From here we can write t is equals to minus b plus minus root over, applying Sridharacharya formula. So t will be equals to plus 2 plus minus root over b square minus 4ac. It will be 12 divided by 2 root 3. So t can be written as 2 plus 4, 6 upon 2 root 3. 6 upon 2 root 3, or t can be written as 2 minus 4, that is minus 2 upon 2 root 3. So t can take either root 3, or t can take minus 1 by root 3. So now it has been given that point P lies in the first quadrant. So if point P lies in the first quadrant, it means that x and y both coordinates will be positive in the first quadrant, right? It means our coordinates is t square, which is already positive. So y coordinate is also going to be positive. It means t will take positive value so as to become positive, right? So we will include t as root 3, and we will exclude t equals to minus 1 by root 3, because it is contradicting that point P will lie in the first quadrant. So now we have we got the parameter t as root 3. So we can put the point P, and so we got point P as, we will put t equals to root 3. So we will be getting coordinate of point P as 3, 2 root 3, and we know coordinate of S as 1, 0. So now our problem has been come towards here. We have PS as a diameter. We know the coordinates of P and S. We need to write the equation of circle. So now how we will do this? So in circle we have already seen, if we are aware about the endpoints of any diameter, we can write the equation of circle. If you have forget, then let me revise you. Since if we have any circle and we are aware about the coordinates of any diameter, let's say it is AB, and it has coordinate as x1, y1, it has coordinate as x2, y2. So we can write the equation of circle as x minus x1 into y minus y1 plus, sorry, x minus x1 into x minus x2, x minus x1 into x minus x2 plus y minus y1 into y minus y2 is equals to 0. How we used to derive this? We use the concept of this thing, that it makes an angle of 90 degree at any circumference diameter. So slope of, let's say this is r, so slope of AR and slope of BR will be equals to minus 1. From there we can assume this r as h comma k, because h comma point r is lying on the circle. So once we will simplify slope of AR and slope of BR equals to minus 1, we will reduce to this equation. It means that this is the equation of circle. Now we can substitute the value of x1 and y1, and x2, y2. So we will be getting equation of circle as x minus 3, x minus 1 plus y minus 0, y minus 2 root 3 is equals to 0. Since it has given that circle passes through 0, alpha. So let's simplify, let's put this point in this equation. So we will get 0 minus 3, that is minus 3. Minus 3 multiplied by minus 1 plus y will be alpha minus 0, it is alpha, multiplied by alpha minus 2 root 3 is equals to 0. From here we can write 3 plus alpha square minus 2 root 3 alpha equals to 0. So it will be alpha square minus 2 root 3 alpha plus 3 is equals to 0. From here we need to simplify to get the value of alpha. So we can write alpha equals to 2 root 3 plus minus root over b square minus 4ac divided by 2a. So it will be root 3. So there will be repeated roots and alpha will be root 3 twice. So it means we got the value of alpha as root 3. We got the value of alpha as root 3. We have been asked to write the value of 5 alpha square. So 5 alpha square will be equals to 5 alpha square will be equals to 5 times root 3 whole square, it will be 3, it will be 15. So 15 will be our right answer. So this was asked in JEE Mains 2025. It was one of the good question. So now what we have done, first of all, we have applied the slope of 1060 degree equals to root 3. Sorry, value of 1060 will be equals to slope and it will be equals to root 3, and that will be equals to 2t minus 0 upon t square minus 1. From there we obtain the value of t as root 3 or minus 1 by root 3. We have taken root 3 because it has been given that point P lies in the first quadrant. So we should make coordinates as positive. So for that reason we have taken t equals to root 3. Now after getting point P and we have been given point S as 1, 0, focus of parabola, we can write the equation of circle using the formula x minus x1, x minus x2 plus y minus y1, y minus y2 equals to 0. Since we have written the equation of circle, this equation of circle, it has been given that circle passes through 0, alpha. Sorry, it means 0, alpha will satisfy this equation. Post satisfying this equation, 0, alpha in this equation, we got alpha equals to root 3, and we have been asked to write the value of a 5 alpha square. So 5 times root 3 whole square means 3. 5 into 3 equals to 15 will be our right answer. So you have been given 2 questions to be done by yourself. The questions you can see here, you can note it down, you can take the screenshots as well. So try it by yourself, give it a try. And this question was asked in IIT JEE 2011. So also we have seen this type of question in today's class. So it means that this type of question is going to play a very important role in your upcoming examinations also, right? So give it a try and try it by yourself. So also go with all the questions whatever we have done in the class and we have discussed. So try it once by yourself to make it your concepts, right, in your own way. So let me summarize today's class. So we have gone with the parametric equations of standard parabolas. Post that we have seen the parametric equations of shifted parabola, and we have seen the flow chart and we have seen the tricks how to remember all the parametric equations of a parabola. So where 280 is always going to become with the positive sign itself, and 80 square will be plus if the sign of 4a will be plus, then 80 square will be plus sign with plus sign, and if sign of 4a will be minus, then 80 square will come with minus sign. So after that we have seen the questions and we have seen the previous year asked questions also. So if you will go with all the questions whatever we have discussed in today's class, it means that you will be able to clear all your doubts related to parametric equations of parabola, whether it is a shifted parabola or whether it is a standard parabola whose vertex lies at origin. So make sure that you go on with the complete videos and try by all the questions, try by yourself once again. So we'll meet you in next video. Till then, take care. Bye bye.